Good morning or afternoon, whenever you guys are watching this. Um, we are on week 10 for Algebra lesson 6.2, slope form, point slope form. And here you have some of the vocabulary you're going to need to know this week. Point slope form, the definition of it is the line with slope m that contains point x and y, which can be described by the equation y minus y1 is equal to m times x minus x1. Um, so, and then this is referring to M. M is referring to slope. The definition for slope is also there. It is a measure of how steep a line is between 2 points. So just a basic reminder of what it is in case you forgot. 2 points, right? There's a line that goes through them, and that rise over run between the 2 points is considered your slope or your M value, right? So we're going to be talking about slope implicitly because you guys should already know what it is. As far as anything that every time I say the word coordinate point, I mean x and y in that order. And right here for this equation, when I say x1 and y1, I'm referring to the coordinate point that you're going to be using, but the regular x and the regular y are going to represent something else. And they're going to come into play when we're dealing with word problems. Okay. So with that in mind, let's move on. So the first kind of problem is how to find the equation of a line in a point slope form using a slope and a set of coordinate points. So the problem just says write an equation in a point slope form. And they give you a given. This is something, the information that they give you as part of the problem. They say let m equal 3.5 and your coordinate point be -3, 2, right? So they give you this information beforehand. They give you one coordinate point and they give you the slope already there for you. You don't have to calculate the slope. This is the easiest that you're going to be able to do this. And here's how you're going to do this. You're going to start with what we consider point slope formula. Now, that's here or right here, right? So point slope formula is this right here. Exactly the way I have it written is exactly how you should have it. So it's y minus y1 is equal to m, or slope, parentheses, x minus x1, close parentheses, okay? That is, the point of this formula is because it is meant for you to be able to build another equation with only two pieces of information, which is one set of coordinate points and your slope, right? That's all it's designed to do. It's just you're supposed to end up with an equation that represents a line, right? And that's it. So how do we do that with 3.5 and -3, comma 2? Well, we're going to have to go on to the second step, which is substitute 3.5 for m and substitute -3 for x1 as well as +2 for y1. Remember, that's what I have up here, right? If you're wondering why is it considered x1 and y1, why can't it just be regular x and regular y? Well, again, regular x and regular y are representing input and output in this case. And that's not really not what we're trying to do. We're not trying to figure anything out yet. We just want the equation. So that's why we needed a way of distinguishing between regular x and regular y, which represent input and output, and x1 and y1, which represent our points or our reference for what in regards to how we figured out slope or how we got slope in the first place. Uh, so anyways, we're going to replace that. So x1 is different from regular x, and y1 is going to be different from regular y. We're actually not going to solve for x and y here. We're only going to keep them as part of our equation. So once we substitute that, right, we're right here, we end up with y minus 2 is equal to 3.5 times, because remember that parentheses implies multiplication, times x minus, and then we're going to put in parentheses -3 inside of parentheses, inside of bigger parentheses. So in case you don't remember, The reason why we do that is because the original coordinate point, my x is negative. So if you go back here, right, we see that our original x is -3. But my equation right here, like if you guys see this, already has a negative there. We can't forget about both negatives, right? So both negatives are going to be present. And the way for us to remember that is to put the -3. When we replace x1 with -3, we put it inside a parentheses so we know that there's two negatives next to each other. So a negative times a negative is going to be a positive, which is why in the next one where it says distributive property, there's a plus there. That negative turns into a plus because the negative and negative multiplies. So if you notice the left side of the equation in this step, right, the second step, I didn't do anything with it. I just said y is equal to 2, which is equal to, now I use a distributive property. Now, in case you can't remember, the distributive property just means I take the number on the outside of the parentheses and I multiply it by everything on the inside. That means 3.5 multiplies by x to give me 3.5x. Right? Because a number times a variable, they just kind of get together. That's really all they do. 3.5 times uh, +3, right? Well, it's technically a -3, but because the negative and the negative were next to each other, I turned them into a positive, and then that way it's a +3. +3 times 3.5 gives me 10.5. Okay, that's how I got those, right? So what do I do now? Well, I'm not done. I have that -2 over here that I have to get rid of, right? So what I want to do is I want to finish isolating the x, right? We've already done that. We've already done this. We've already done this. And we've already done this. We just need to finish isolating the x. That means the x has to be by itself, which means I got to get rid of that too. And since it's currently subtracting, I just add 2 to both sides of the equation so that it cancels out on the left side of the equation. And I can just add it to the 10.5. I can't add it to the 3.5x because 3.5 is multiplying by x, but I can add 2 to just the regular 10.5. 10.5 is a regular number. Okay, so when I add that together, I end up with my final equation of y is equal to 3.5x plus 12.5. That is my final equation, and now my equation happens to be in point slope form, right? So which is what the problem was asking us. The original problem says write the equation in a point slope form. That's what we did. That's our answer. Our answer is just the equation. I'm not going to end up with any numbers or anything else. That's it. I don't have to solve for x. I don't have to solve for y. If all the problems are asking you, and like the first couple problems in the homework and practice are going to be like this, where they just say, hey, here's an m, and here's a coordinate point. Can you write an equation in point slope form? And your job is to do what I just did right now. Follow these steps. You should be fine. You should end up with a regular equation. Okay. All right. So the next type of problem that you're going to encounter is how to find the equation with 2 points and no slope. So what happens if they change up the problems on you and they say, okay, cool, you know how to make an equation in point slope form if you're given the slope and 1 point. What if I give you 2 coordinate points and I don't give you the slope? Is it possible to still get an equation? The short answer is yes. If you have 2 points like this, for example here, problem, write an equation um, in point slope form for the line containing points 2, 1, and 3, 4. What that is just saying is just I have a line and that line contains 2 points, these 2 points specifically. Can you tell me what the equation for this line in point slope form is? And the best way to do that is to, well, you're going to need to find the slope first. And that's using a different formula. So if you notice, I have this top part, right? It's separated from the other steps because it's a separate step in its own. You're going to have to find slope using the slope formula. Now, we went over slope formula a couple weeks ago, so I need you guys to remember that lesson. But a quick rundown is here, what I have here is the slope. formula. M, which represents slope, is equal to y2 minus y1 over x2 minus x1. So how do I find out what my x1 and y1 is and my x2 and y2? Well, you just kind of pick a coordinate point, and then you just, which one you want to put first doesn't really matter. You're going to end up with the same answer at the end of the day anyways. In this case, you see how I have 2 and 1? I made that my x1 and my y1. And the next coordinate point, just because it came after, I made that my second one. So this is going to be x2 and y2. Right? In this case, y2 would be 4, x2 would be 3, y1 would be 2, and x1 would be 2. I'm sorry, y1 is 1, and x1 is 2. All right. So all I have to do now is plug those numbers into that equation, into that fraction, and just subtract. So again, 4 minus 1, right, over 3 minus 2. I got that. I just replaced those numbers exactly where they're supposed to be, and I put the minus sign in between them. 4 minus 1 is just 3. 3 minus 2 is 1. I end up with 3 over 1, right? Which is the same as just saying 3. So even though they didn't tell me what my slope was, I could easily find it by just using the slope formula, right? So in this case, I know moving on that m is equal to 3. Now I know what this is. I can do, now it becomes a problem very similar to what I just did in the previous one, in the previous slide, okay? All you have to do now is you just have to decide which coordinate point you're going to use. You can either use 2 comma 1 or you can use 3 comma 4. It doesn't matter. You're going to end up with the same answer. I verified it before I did this. So what do we do? Well, we're going to start like in the last problem. We're going to start with slope intercept form, which is this thing, right? We're right here. Y minus y1 is equal to m parentheses x minus x1 close parentheses. This is our original. This is our original point slope formula, and we're gonna plug in your m value, which you just found out to be 3, and one of the points. I picked point 2 to 1 for this example, right? I picked the first coordinate point just because it was first. That's literally the only reason I picked it. I could have picked 3 and 4, and I would have gotten. I'm gonna get the same answer if I picked that one too. The numbers just look a little different, but you end up getting the same thing. So anyways, I substitute what I know. So if I'm going to use 2, 1, right? 2 would be my x1 and 1 would be my y1. So y minus my y1, y minus 1 is equal to 3, which is my slope, parentheses x minus 2, right? So now that I have that, I just have to distribute the 3. 3 multiplies by everything on the inside, right? That means that 3 times x is just 3x, and then 3 times negative 2 is going to be negative 6. Once I'm at that point, I just need to finish isolating for y, which means I got to make sure y is by itself, which means I got to look at what's next to y. On the left side, I have y minus 1. Since it's subtraction, I do the opposite. Uh, Opposite of subtraction is addition, so I add 1 to both sides. This cancels out, leaving the y by itself on the left side of the equation. And then I add 1 on the right side of the equation. 1 can't add to 3x, but it can add to the regular minus 6. So negative 6 plus 1 ends up with negative 5. My final answer, my final equation for the 2 points is going to be y is equal to 3x minus 5. This is my final answer. Okay, so what's our last thing? Our last thing is using the point slope formula to solve word problems, right? This is an example of the kind of problems you're going to have to do for the second half of your homework, right? And just so you know, a lot of it is reading comprehension, but given that this is the last week that you guys are going to be doing new problems, uh, it's not going to be that bad. You'll have time to do all these. So problem. Paul wants to place an ad in a newspaper. The newspaper charges $10 for the first 2 lines of text and $3 for each additional line of text. Paul's ad is 8 lines long. How much will the ad cost? Okay, so the key with these kind of problems is you have to look at what they're giving you and organize your information in a way that makes sense. So that right here, I kind of wrote it out for you, but it says, okay, we need to find out what X represents, we need to find out what Y represents, and we need to figure out what all of our variables represent. So how did I do that? Well, I looked at the problem. Paul wants to place an ad in newspaper. Okay, that doesn't really help me. The newspaper charges $10 for the first 2 lines. Okay, that's important because 10 is going to be one of my variable numbers. 2 is also going to be one of my variable numbers of text, and $3 for each additional line of text. Paul's ad is 8 lines long. How much did the ad cost? Okay, so we went over, there's a couple things, right? We know that X represents the number of lines in the ad, right? And we know that Y will represent the cost in dollars. Why? Because the problem is asking us at the end, how much will the ad cost? This is ultimately what the problem is going to get us. And since that's what we want to know, and we're going to use point slope formula, the final answer in a point slope formula is going to be Y. So that Y kind of represents our final answer. So really what it's asking us, how much will the ad cost? That's Y. That's why I said let Y represent cost in dollars, because that's the final answer that we want. Okay, and then if Y is the final answer that we want, X is something that we're going to have to input in order to get that. Well, how much will the ad cost? Well, it depends how many lines Paul's ad is, right? They straight up say Paul's ad is 8 lines long. So that means X has to represent the number of lines in the ad, right? In thinking about this, if Paul could use the same equation to figure out if he wanted to add more lines, how much it would cost. Any number of lines would, in theory, change and change the price, and we could figure out the price change. For here, they just tell us he wants an ad that's 8 lines long. So how much is that going to cost? Right? Okay. Now the last thing. Okay, so we know what our X is, we know what our Y is, but what about X1, Y1? What about M? Don't we need those too? We do. And the best way they can figure that out is the first part of information. The newspaper charges $10 for the first 2 lines, right? So with that, they give you the coordinate point. Remember, your coordinate point is represented by X and Y as well. I know this can be kind of confusing. So I'm gonna label these my X1 and Y1. Your X1 and Y1 in this case are referring to specifically to how much everything will be charged for. So here, the newspaper charges $10 for the first 2 lines. That means that if he only had 2 lines of text, right? If he only had, that's my input, and inputs are X's. So if he only had 2 for an X, what would his Y be? His Y would be 10. So even though they didn't tell me straight out, they kind of did. With that first line, I know that my coordinate point is actually 2, 10. And the slope in between those two, I could, if I wanted to, um, figure out the slope in multiple different ways. But here, really, they tell me what the slope is too. It says $3 for each additional line of text, right? That means for 1 extra line, right, I'm going to rise up $3 in charge, right? So with that in mind, 3, my M is 3. Okay, so I know that was a lot, but we have all of our information. Now comes the easy part of just plugging it into the formula. We're going to always start the same thing with point slope formula, right? Then we're going to substitute the known information. So y minus 10, we're going to plug in these three pieces of information first, right? My y1, which is $10 for the first two lines, which is my x1, and with a rate of $3 per additional line after that. So that's going to be 3 as my m. So I'm left there. However, in order to find the cost of dollars, you need to solve for y. When specifically when x is equal to 8. That's that second piece of information. That's what the original x and y. That's why there's a difference between x and y and x1 and y1. They don't represent the same thing. All right, so now when we plug it in, y minus 10 is equal to 3 times, parentheses, 8 minus 2, close parentheses, right? So then y minus 10 is equal to 3 times 6, right? So what I'm going to do is, I kind of skipped a couple steps here. I did them out of order, but 3 times 6 is going to be equal to 18. And then once I have y minus 10 is equal to 18, I'm going to want to add 10 to both sides. And I'm left with y is equal to 18 plus 10. Y is equal to 28. So to answer Paul's original question, the cost of 8 lines is $28. And that's pretty much it. If you're wondering, well, in the real world, I would just add and find the answer. Yeah, you could. You really could. But when we start, this is a fairly simple example. The reason why we even have this in the first place is because when we're dealing with large numbers or more complicated numbers or more complicated real world examples, this formula can make those problems much, much easier. And that's why we do this in the first place. That's why we're learning how to do this. With that in mind, a couple of announcements. So this week, week 10, will be the last week that we upload new assignments. Week 11 will be a catch-up week. I'll post more information on Google Classroom for you guys. But just know that look out for any announcements that are going to come your way. And the quarter is really close to being done. So for those of you who hung in there, good job. You're almost done. Just turn in your last homework. Do your best on it. Turn in everything, and it'll be over. Also, keep a lookout for some more announcements that we're going to do on changes into the next quarter if you are one of those people that need classes for the next quarter. So with that in mind, don't forget to do your homework and practice. Problems numbers 2 through 14 due on Sunday. All right, don't forget to upload your notes and answer all your daily warm-ups. All right, man. All right, everyone, have a good night.